Today we will discuss two things. The first is the theory of relativity. The theory of relativity. And the second is quantum theory. Before starting the chapter, bear in mind that according to relative theory, according to what? According to relative theory, a moving clock appears to run slowly as compared to clock at rest. As compared to clock at a satellite is moving with some high speed and it is contains some clock. Now the speed of this clock will be appear as running slowly as compared to another clock present on earth surface. So this is the point, always bear this in mind. So starting the relative theory, the first one is the reference frame. That what is reference frame? Reference frame. All motion must be measured in some particular reference frames, which we usually respect a set of coordinates axes. A body is moving. How can we say that this body is moving? We will write x-axis and y-axis are in case of 3D z-axis, and we will say that first the body was at this position. After some time it changes its position from this point. So we take this xyz plane as a reference, and with this reference we can say that the body is moving. Without the reference we can't say that the body is moving or not moving. For example, a spaceship, if the spaceship is moving in sky or space, if the spaceship are moving in space without any space in its surrounding, so it can't feel that it is moving with high speed. Now if there are some stones or anything in space, now to take the stone as a reference, we can say that first the ship was at position A, after some time it get position B, so we can say that the ship is moving. Without looking to its background or its surrounding, a spaceship can't feel that it is moving with high speed. So to measure the motion, or the motion is measured by always by some particular reference frame. Now there are two references. The references are, for it is also remember that there are two types of references. The first one is inertial references, which has no acceleration, or the reference that is at rest. The second one is non-inertial references, which is moving with some velocity on which acceleration is present. Now in non-inertial reference frame, body have acceleration in the absence of applied force, because the reference frame is itself an acceleration. Now inertial is no acceleration. A term no acceleration is used for reference frame. So all those reference frames are inertial, which are at rest or which no acceleration occurs, and non-inertial are those references in which acceleration occurs. Now Newton's laws do not hold good and appropriate in real life. The real forces, for example, if there is non-inertial frame, acceleration is occurring, the body is moving with some acceleration, or the reference frame is moving with acceleration. Now to compare, so for reference frames we have two types of reference frame. The one is inertial, the second one is non-inertial. Inertial are those in which they have no acceleration. No acceleration. Inertial references have no acceleration, while the non-inertial have acceleration. And these forces which have acceleration is present in this references Newton law doesn't hold good. Newton laws doesn't hold good, because in Newton's law there is acceleration. So if at the reference is moving, so we can't take it doesn't hold good. For example, if taking this is a reference, a body is moving from position A to position B, and this is another object or stone or building, if this is suppose building. So if we can say that first the body was near the building and second the body was far away from building, so it is, we can say that it is accelerated. Now if the building is moving, or instead of building there is a train, if the train is moving and the train is moving and you are also moving, though, then the laws will not hold good, because you can't find the correct acceleration value. Because if you compare your value with the reference, if you take the reference as train, so the train is moving, the train have acceleration, so your acceleration value will be not good. So in reference non-inertial plane where acceleration occur in reference, the Newton law doesn't hold good. The Newton laws hold good in all inertial references frame without the addition of frictional forces. Here we will add no frictional or any other forces, because the reference is at rest. For example, if we take this as a reference, if we say the body was at position A, then it get position B. So this is the total distance. The distance, velocity or anything we have to find acceleration or Newton law, we can take this as a reference. This is inertial reference. So without adding anything, we can use this inertial reference. In the second case, in non-inertial, if this is the body or train, if this was the position of A and the body moves to the position is B, but as the body is moving from A to B, the train is also moving, so the train will get its position here. So you can say that the train was 10 meter further from me, but after some time you will say that I am with the position of train, so I have measured 10 meter distance, but in reality you have measured 10, 20 and 30 meter. So in this case you will add the friction of what? 20 meter or any other force. So in non-inertial frame, if you apply the Newton law, you will add all these pseudo force. Pseudo means small forces or any other thing you will be added to get correct value. So in non-inertial frame, Newton law doesn't hold good, but in inertial frame, Newton law holds good. For many purpose, the earth surface is considered as inertial. Earth is considered as inertial. Inertial means that is not moving, that is at rest. But earth is moving, it is rotatory around, its own axis is moving around the earth. But if we consider the surface of the earth, we can say that we are moving and the earth is not moving. We consider the earth is inertial, although it is not, but we consider it that the earth is inertial. So Newton law holds good on earth surface. The next is special theory of relativity. Special theory of relativity. So this law states that the first statement is that all the laws are the laws of physics. Physics laws. Laws of physics are same in all inertial frames. If you have two frames, all inertial frame means every inertial frame. So I take two frames. The first one is the building. The second is, for example, if we have considered it as some type of home or any other reference of any other reference. So if we have three inertial frames, 1, 2, 3, A, B, C. If a body starts A moving with to position B, or in this case if a body moves from A to B, if a body moves from A to B. In all these cases, as the inertial frames are at rest, so it doesn't depend on inertial frame. So physics laws hold good in all inertial frames. It was first stated by Galileo and embodied in Newton's first law. The second is the speed of light in vacuum is same in all inertial frames regardless of the motion of source of the observer. Speed of light is same in all inertial frame, like laws of physics is same in all inertial frames regardless the motion of source or observer. Principle of constancy of speed of light. Regardless means doesn't depend on motion of source or observer. For example, if this is the source of light is producing. Speed of light is produced from the source. If this body is moving or not moving, but the light rejected or the light will move with its constant speed 3 multiplied 10 raised to the power 8, or if the observer is moving, observer is at this position or this, the speed of light will not affect him, with the speed of light will be constant in regardless all the motion of source or observer. This second portion just shows us that the speed of light is constant and doesn't depend on source or observer. Now, in the theory of relativity, which assumes that velocity of light is constant, this one, velocity of light is constant, then time is relative as well as space. Velocity is constant while the time is relative as well as space, while the time is relative to space. What does it mean? That time will be passed differently from different bodies. If the body is moving with the speed of light, then there will little effect of time, depending upon how the body are moving, or in other words, time passes differently for different observer depending upon how fast they are moving. The velocity does not depend on observer motion or the source, but the time depends on observer motion or force. Now, there are consequences of special theory of relativity which we will discuss one by one. The first one is the relativity of simultaneity. The relativity of simultaneity. The relativity of simultaneity. The relativity of simultaneity states that whether or not two events are seen, whether or not two events mean two activities are seen by you. If you see any two activities, be simultaneous depends upon where are you standing. It will depends on your position. How can we explain it? We can explain it as, if this is a train, one room or one part of the train in which door is present on both sides of the room. Now the doors are automatic. By one click, both doors open and closes continuously. And at the middle of these, this is bulb. Bulb is present. Now someone is sitting or standing here in this position. If both doors open, the light will goes and will be reflected from doors. So as both doors are at same distance and both at the same time open and closes, so the object this body will see that the both door closes and open at one time, as both are automatic. So this is a body A, observer A. Observer A will say that both doors A and B, it will say that A and B door open and closes at same time. He is right now, because doors are automatic and by one click it's open and closes, and at a distance of due to bulb he will see it, and he can say that the door I testify that both doors open and close it at the same time, and he is right. In the second case, if you are standing in this position, position C, you are present in position C and the train passes. The train passes in front of you while at the same time the door open and closing. So at this time, if this door opens and closes, the light will comes to you. And in this cases, if this door open and closes, the light will also come to you. So we can say that there is this light A, light, if we call it light X, and this light we call it light Y. So we can say that light X is further from light Y. Light Y is short and light X is more. So it will take more time to reach to your eye. So as it will take more time to reach your eye, so you will say that door A closes directly while B closes lately. So you will say, because body C will say that door A open and closes first, while door B open and closes lately, and you are also right. So the two events, if this is two events, these are occurring, it depends upon you that where you are standing. If you are inside the train, so you will say that both are at same speed, so both open and closing at same time. But you are outside the train in this position, you will say that A open and close first, while the second is open and closes late, and both are right. So this is the relativity of simultaneously. That whether or not two events are seen by you be simultaneous depends upon where you are standing. The next is equivalence between mass and energy. By this we mean that equivalence between mass and, it means that mass can be converted into energy and energy can be converted into mass. Now we have electron, its mass is 9.11 multiplied 10 to the power minus 31 kg. If we want to convert this electron into energy, how much energy it will give? So the energy which will be produced is equal to mc square. If we put any mass here and multiply it by square of the light, which is 3 multiplied 10 raised to the power 8, and here is square, so the mass is 9.11 multiplied 10 raised to the power minus 31. So it will give us 8.1 multiplied 8 by 10 raised to the power minus 14 joule. So if we convert one electron into energy, it will give us 8.1 multiplied 10 raised to the power minus 14 joule of energy. Now if you want to convert this energy into electron volt, for that we will use that 1 electron volt is equal to 1 joule, or 1 electron volt is equal to 1.602 multiplied 10 raised to the power minus 19 joule. This is the relation between electron and volt. The next is A body is moving at high speed. So what will happen? A body is moving with high speed. So what will happen? Its length will be contracted. Length contraction will occur. To learn this or to make your concept, how will you say that length is contracted? Actually length is not contracted, but we will see that a body is moving with velocity, we will say that it has been shortened than its real value. So for example, this is some stick and it is moving in front direction. So to measure its length, what we do? First we see its one end, then we see its second end, and we do calculation in our mind that we can say that it's maybe 2 or 3 feet. To measure the length, how much length is this pin? So we will see its first end and then we will move to its second end, then we will say that this is about half feet, right? So if this is moving, what will you do? This is moving in this position. We will say that first at this point is this. So you will save this point in mind. The next you will move your eyes towards another end, but at the same time as the body is moving, so as you move your eyes to this point, it will reach to have its next position because it is moving. So you will get this point is here. You will say that the second point is this, because as you are moving your eyes to this direction, the body is moving, so you will note these 2 points and the real length was this. So when a body is moving at high speed, its length is contracted, and length contracted, remember the brain, length contraction means length will be contracted or shortened. The second is mass dilation, mean mass will be increased, and the third one is mass dilation, and the third one is time dilation. Each one has its own formula. For contraction we will use that L is equal to L naught 1 minus V square divided by C square, where L naught is original length and this is observed length. So issue done. They shall V is velocity and C is the speed of light. Now formula for T is equal to T naught, and for dilation we will divide by 1 by V square divided by C square under the root of. Next is M is equal to M naught 1 minus V square divided by C square under the root. Now if body is moving with high speed, then its length is contracted. So the greater the speed, the greater will be the contraction. If it is moving with high speed, the length will be decreased. So suppose if we say that the body is moving with the speed of light, what will happen? If it is moving with the speed of light, means its velocity is equal to c. Putting it as this equation, we will get L is equal to n naught 1 minus c square divided by c square under the root. C square cancel with c, 1 minus 1 is equal to 0, under root 0 is equal to 0, 0 into L naught is equal to 0. So its length will be equal to 0. If body start moving with the speed of light, you will see nothing, and its length will be contracted into the 0. Done. And next is what will happen to the mass. Mass increases with as the body moves fast. So if the body move with the speed of light, its length will be increased as much as infinite value. So how? Putting velocity is equal to c. So we can say that t is equal to t naught 1 minus c square divided by c square. C square cancel with c square, and 1 minus 1 is equal to 0, under root 0 is equal to 0. So t naught divided by 0 is equal to infinite. So its mass will be increased to up to infinite value. Now what will happen to time if a body is moving with the speed of light? So if body is moving with the speed of light, this is time dilation and this is mass dilation. So m is equal to m naught 1 minus, putting v is equal to c square by c square under the root, c cancel with c, 1 minus 1 is equal to 0. So m naught divided by 0 is equal to infinite. So a body is moving with the speed of light, then its length will be equal to sa, and its time will be infinite, and its mass will be also infinite. 1 minus 1 minus 1 1 minus 1 0 बचे. So these are the 3 points you must remember it in eta. For eta you must remember. How can it is possible? Now if they say that the body is 100 meter length, the body length is 100 meter is the body length, and it is moving with the speed of what? 0.99 c. Speed of light, it is, they give the speed as 0.99 c, but it means that these are moving with 99 by 100 multiplied by speed of light. It is moving with this speed. Now what will be the observed length? What will be the length? So we know that L is equal to L naught 1 minus v square divided by c square under the root. So L naught is equal to 100. So 1 minus v is 0.99 c square divided by c square. They will give speed is in the palm of c. So 1 minus 0.99, take a square of 0.99, 9 9s are 81. So in case of 0.9 we will get answer is 8.1, and square divided by c square. So c square divided by c square. Now 1 minus 8.1 is equal to 1.9. Now 1.9 into 100 will give us some value, that is 14 meter in this case. So the original length was 100 meter, but as the body moves with the speed of nearly speed of light, not with c, but 0.99 c, so it is 14 meter. Now if this body starts moving with the speed of light r 1 c, then it will 0 meter, and if it moves with 0.5 c, so it will give value then greater than 40. So as the speed increase, the length is contracted more and more. And next is black body radiation. Any object are all objective at given. So anything or any object that have some temperature will radiate some waves or particles, and this is called thermal radiation. Now the radiation energy, radiation wavelength and radiation frequency will depends on the temperature. So greater the temperature, if temperature increases or greater is the temperature of the body, the waves released will be of high energy. So energy will be high. So now we know that E is equal to HF, F is equal to C divided by lambda, so H is equal to C divided by lambda. From this equation we see that H is inversely proportional to lambda. So if temperature is high, the waves radiated will be of low wavelength. As temperature is high, waves are high energy. So high energy means these wavelengths is minimum or less. So less or minimum. In other case, if temperature is less, the energy will be also less of particles or waves or radiations, and the next their wavelength will be more. Their wavelength will be more. So for low energy, the wavelength is in terms of infrared, and for high energy it is ultraviolet, and at the center this is visible. So the ranges of rays starting from infrared, passing through visible and reach to the visible. So this was thermal radiation. The next topic is The next topic is same, black body radiation. In black body radiation, we have two laws. The first one is called wind displacement law. According to this law, lambda maximum T is equal to 0.2898 multiplied 10 to the power minus 2 meter Kelvin. So this is called wind displacement law. It states that when increase in temperature, the peak of the distribution shift to the shorter wavelength. If this increases, the wavelength will be decreases because its product is always remain constant, and this is its value. Or if we decrease the temperature, the wavelength will be increases for radiations. And this equation is used for to find maximum wavelength if they have given us the temperature. For example, if they give us that the temperature of skin is 35 degrees C, then find the wavelength at which peak occurs. Now we have to find the wavelength at which peak occurs is lambda maximum. We have to find this. So we know that lambda maximum T is equal to constant, that is 0.002898 or 0.2898 multiplied 10 to the power minus 2. Now converting the degrees into Kelvin, so we will add it 273 with this, so then we will get 308. Now to find the lambda maximum, we will divide 0.002898 by T, that is 308, and we will get our answer is 9.4 micrometer. So this is the use of wind displacement law. We can find the wavelength by given temperature. The next is Stefan-Boltzmann's law in this topic. Stefan-Boltzmann law. In Stefan-Boltzmann law, the energy is directly pushed on 4 power of temperature. We are putting constant, equality constant alpha, so this alpha is called Stefan constant, and its value is equal to 5.67 multiplied 10 to the power minus 8 W meter minus 2 K minus 4. Now if they give us that the temperature is increased 2 times, or we make the temperature double, what will be the effect of energy? So if they double the temperature, mean they make T to the 2T. So putting here in this equation, we know E is equal to T to the power 4 alpha T to the power 4. So E is equal to alpha 2T to the power 4. So E is equal to alpha 2 to the power 4 is equal to 16T. So E will increase 16 times. So if we double the temperature, energy will increase by 16 times. Now if we double the temperature, energy will increase 16 times. If we made the temperature 3 times, then in that case we know that E is equal to alpha to the power T to the power 4 alpha 3T to the power 4, so we will get 81 alpha T to the power 4 or 81 E. So if increase T times 3 times, then the increase in energy will be 81 times. So this is Stefan-Boltzmann's law. This is part. The next is, there are many a series of attempts which were passed and failed for short or long wavelength. So Relativity, this is a scientist, Relativity. His attempt failed for short wavelength. Same. He failed for short wavelength, but his attempt passed for long wavelength. So remember, Relativity failed for short wavelength. The next was Wenz. Wenz was scientist, his attempt failed for long wavelength. So remember, when long mean when failed for long and passed for short. In opposite is Relativity. Relativity is a scientist that failed for short. So these are 2 points. The next was quantum theory. Planck's quantum theory. There are 2 postulates of Planck's quantum theory, or 3 postulates. Planck's quantum theory. The first one is that all the objects that radiate radiation, these radiation are in the form of small waves or packets, and this is called, and the energy of these packets will be the multiple of hf. So energy of packets is equal to nhf, where n is integral number starting from 1, 2, 3 and so on. It means that all the energy released is the multiple of hf. Either it will be 1hf or it will be 2hf or 3hf, but not the value will be not and be like 1.5 hf, not 2.5 hf, but it will be always is equal to 1hf, 2hf. It means that these are in the form of quanta or small packets. So this is not possible, and these states are called quantum states, where h is Planck constant, its value is equal to 6.62 multiplied 10 to the power minus 34 joule second. The next is the molecules emit energy in discrete units of light. These particles, these wave, if these are particles of light, so in that case we will call it photons, and its energy will be is equal to hf nhf. So we can also say that its energy is equal to nh. We can write c divided by lambda instead of f. So the energy is inversely proportional to the wavelength. So if these wave have high energy, it means they have short wavelength. If this is less energy, these packets have less energy, it means its wavelength is high. The next is photoelectric effect. अब ये साल के अब एक भी अंदर राजमा अब एक अंदर राज अब आप 4 टाइम इंक्रीज की 16 टाइम कट की 2 square 3 9 of these things. The next is photoelectric effect. So if we expose a metal surface to a light, or we let the light to hit a metal, and electrons will remove from the metal, and as electrons remove, these electrons will start motion. So these electrons which are removed by due to light, so these electrons are called photoelectrons, and this process is called photoelectric effect. It has been observed that metals when exposed to light or X-rays or gamma rays, they emit electrons, and this process is called photoelectric effect, and these electrons is called photoelectron. They are called photoelectron. Here photo word means light. They are called photoelectron because these electrons are produced due to or emitted due to light. So this is called photoelectron. Now to check this process, we will take metals A and B, and we will connect it to the battery or galvanometer to check whether current is produced or not, and we will choose connect resistor to use this energy. So if this apparatus is kept in dark, so no electrons will be produced, but if we keep this apparatus in light, the light will come, it will hit the metal A, the electrons will be removed from A and it will move towards A, and now that electrons will move in circle. So when this electron passes to galvanometer will show us a deflection. It means that electron is produced. Now this current, the current that is produced due to photoelectrons is directly proportional to the intensity. Greater the intensity, greater will be the number of electrons produced. Greater number of electrons produced. Not electron will get much energy or greater kinetic energy. Why with the intensity increase, current increases? because when the intensity increases, greater number of electrons will be emitted and greater electrons will move and more current will be produced. So this is the point for entry test. The intensity is directly proportional to the current produced. The next, if we connect voltage to it, due to this battery, the electron will attach and move towards the battery. If this potential is less, so if we connect less potential, then electron will be emitted by light, but these two metals have no such potential. The metal B has no such potential to attract the electron. So no movement of electron will be occur, and that potential is called stopping potential, or V naught. This is called stopping potential. What is stopping potential? The potential applied so that it is not enough to attract the emitted electron. This is called stopping potential. And the stopping potential has no relation with the intensity. It has no relation with the intensity. It depends on the applied voltage. So we know that intensity current produced is directly proportional to the intensity. This is point 1. The next point is why? Because greater number of electrons will be produced. This is point 2. The next is intensity has no relation with V naught, that is stopping potential. Done? Now there are some results which have no background, where we have no background for it or no proof, but this is just experimental result, and you must remember that what are these results. So the brighter light cause increase in current. So greater the brighter light, greater will be the current produced. Why? In same case, because greater number of electrons will be produced. This is point number 4. The next is greater number of electrons will be produced, but not electron will get maximum kinetic energy. This will get not possible. So the reason is brighter energy cause increase in current. Why? Because greater number of electrons will be produced, not electron will get maximum kinetic energy. Done? The maximum kinetic energy is independent of intensity or brighter light. But what? This kinetic energy or kinetic energy maximum depends upon the frequency. Our kinetic energy does not depends on intensity, but it depends on the frequency. Point number 5. The next is there is threshold frequency. Below that frequency no electrons will be emitted. If we increase the intensity so high, but if the frequency is not that in threshold frequency, no electron will be produced. So below this is F naught is equal to threshold frequency, no electrons produced, whatever intensity is. Below F naught means threshold frequency. Below threshold frequency no electron produced, whatever intensity is, whatever the intensity value is. If we get it so maximum, but still no electron will be produced because the value is less than threshold frequency. The next is if energy in photoelectric effect comes and hit the metal, the electron will be removed. But the electron must need some time to absorb that energy and remove, and that time is 10 raised to the 4 minus 9 seconds. So this time is enough for electron to absorb energy and remove from the surface. So this is the time, and you must remember this. So 0.6, 0.7 and point, these are 8 points according to Bhutan quantum theory. You must remember it for all anti-trace. The next is Bhutan theory of electric effect by Einstein, by which he received Nobel Prize in 1921. Bhutan theory of photoelectric effect. So according to this, Newton state that when energy or light comes, of light comes and it hit a metal. When energy comes, so the light must have energy is equal to E, of which its energy is equal to Hf. So where will this energy go? The electron will absorb this energy and will come out of the surface. So the energy that absorbed by electron and to come out of the surface is called work function of that electron. So this is called work function, and this is the energy required by electron to remove out of the metal surface, and it is only for few electron volt. It is very less. So if light energy comes of energy Hf, it hits the electron will absorb work function energy. It is the energy that is required to come out of the surface, and then it will start moving with maximum kinetic energy, and it will move with the kinetic energy. So what happened here? Energy conservation applied. So energy applied is converted into work function plus kinetic energy maximum, or is equal to Hf is equal to work function plus kinetic energy maximum. To write the equation for kinetic energy maximum, we will move it to the left side. So kinetic energy maximum is equal to Hf minus work function. So this is the equation, and this is called Einstein photoelectric equation. Einstein photoelectric equation. Done? How to derive this equation? The next is, if the electron comes out but its kinetic energy is 0. If electrons come out but it has no much energy to go in with some velocity, then it means that light comes of energy Hf, an electron absorb it and just come out of the surface but not have much energy to move forward. So in this case, it means that is kinetic energy is maximum is 0. So kinetic energy maximum is equal to Hf minus flux naught is equal to 0 is equal to Hf minus work function. So Hf is equal to work function. So the whole energy that came is converted into the इलेक्ट्रॉन या जितनी भी एनर्जी आई Hf वो सिर्फ वर्क फंक्शन में ज़ाया हो गई और इस्तेमाल हो गई. सो Hf इज इक्वल टू वर्क फंक्शन. So putting this work function here, we will get is that kinetic energy maximum is equal to Hf minus Hf naught. Replace this by Hf naught. So this is the equation. Now if they give an MCQ that a light wave came of energy E. So if they give us the energy or they will give us frequency sometimes, then we will find from frequency, we will use this equation to find the energy. Or if they give wavelength, we will use which equation? E is equal to hc divided by lambda, where h is constant, c is constant, and by putting wavelength we will find the energy. Suppose they give us that a light of wavelength, a sodium surface is illuminated by light of 300 wavelength. It means it light energy came of 300 wavelength or 300 nanometer and hit the surface, and electron was removed, and the work function per electron was 2.46 electron volt. Now find the kinetic energy or maximum kinetic energy. So we know that kinetic energy maximum is equal to Hf minus flux, Hf minus work function. So work function is equal to 2.46. But what about the Hf? So they have given us wavelength. So we will use E is equal to hc divided by lambda. This is the equation. Instead of Hf, E is equal to Hf or hc divided by lambda. We will use this equation. So H value is equal to 6.63 multiplied 10 raised to the power 6.63 multiplied 10 raised to the power minus 20, where C is 3.8 multiplied 10 raised to the power 8 and divided by lambda, which is 300 nanometer, and nano is equal to 10 to the power minus 9. So we will get the energy that is 6.63 something joule. Now we will convert this joule into the electron volt, where we know that 1 electron volt is equal to 1.6 multiplied 10 to the power minus 19 joule. So converting this equation, we will convert this joule into the electron volt, which is here in this case is 4.14. So my 4.4 minus that is equal to 1.68. So 1.68 is the energy, maximum kinetic energy. The next is Compton effect. Compton effect, the change in wavelength between a scatter X-rays and incident X-rays is called Compton effect. It says then a wave came of wavelength lambda and hit the electron. Then electron will start motion in one direction, and there will change occur in the wavelength. It is 1, then it will become h lambda 2. So lambda 2 minus lambda 1 is called delta lambda, and this is called Compton effect. This is the change in wavelength delta lambda between a scatter X-rays and incident X-ray is called Compton shift or Compton effect or Compton shift. When X-rays come and hit the electron, change in wavelength occur. Why change in wavelength occur? Because if this is X-rays, it is coming, so it must have some sort of energy. So X-ray with energy 1 came and hit the electron. So the electron is at rest. So electron will start motion with some velocity. So as electron start motion, so it gain energy. X-rays came, give energy to electron, and electron start motion. So its energy will be decrease. Its energy will be decrease. So X-ray energy will decreases. X-ray energy of X-ray will be decreased because it has given some energy to the electron that start motion. So we know that E is equal to HF or H is equal to C divided by lambda. If E decreases, then wavelength increases. So in this case, the wavelength lambda 1, lambda 2. So it is lambda 1 minus lambda 2. If it hits the electron, its wavelength will be increases. This is lambda 2 and this is lambda 1. So if hit electron, its wavelength will be increases and energy will be decreases. So a change in wavelength is called, now the change in wavelength is called Compton shift or Compton effect. Now in this case, when X-ray came and hit electron, both laws of energy and momentum must be conserved. So we know that if incident photon comes with energy of HF and hit the electron, so the electron will start motion with the some sort of kinetic energy, and this is called kinetic energy. The next, the photon wavelength will be energy will be changes, and we will call it HF dash. So here what happened? Here HF is converted into kinetic energy plus HF dash. So this is the law of conservation of energy for Compton shift. The next is the conservation of momentum will be also occur. For example, if the wavelength is momentum of this P dash and P naught is the while this is the momentum of scatter wavelength and P is the momentum of electron. Then according to conservation of momentum, P will be equal to P naught plus P, or P dash is equal to, we call it P dash, so P is equal to P naught plus P dash. So this is the conservation of momentum. Now according to classical magnetic theory, each electromagnetic waves carry momentum of magnitude according to classical electromagnetic theory, momentum is equal to E by C. This is the formula. P is always is equal to E by, where E is the energy and C is the speed of light. So as P is equal to E by C, so we can also write that P is equal to HF by C, or we can also write that P is equal to, now here F by C, we know that V is equal to F lambda or C is equal to F lambda, while 1 over lambda is equal to F by C. By F by C I can put 1 over lambda, so I can put P is equal to H by lambda. So this is per points, that P is equal to HF by C, or P is equal to HC by F, or P is equal to HA or CF by H. So which one is correct equation? This is the correct equation. So must remember this equation, that P is equal to E by C, where E is equal to HF. Now also remember that P is equal to H divided by lambda. Now using the incident photon direction as x is this is, we can separate into two components for x axis and y axis, but there is no need for further calculation. Just remember the formula for delta lambda. So the formula for delta lambda is equal to H divided by m naught C n 1 minus cos theta. This is the Compton effect. Now for frequency, where H divided by m naught C is called Compton wavelength because it is the dimension of wavelength. So must remember its dimension. Now there is rule per dimension. H each is equal to m naught C. They can give you in eta that H divided by m naught C is the dimension of what? So this is the dimension of meter, so its dimension is length. So how? Without calculator we can found it. How? We know that if there is something on equation right side and left side, H divided by m naught C, and 1 minus cos theta is number, so is dimensionless. So if there is equation, the right and left side both have same dimension. The wavelength dimension is meter, so its dimension will be always is equal to meter. Like W is equal to FD, so what is the dimension of work is the dimension of FD, because both are equal. So in this case H divided by m naught C is the dimension of length, and it is, this is the dimension of H divided by m naught C, and its value is equal to 0.00243. So this is the most important point. The next is to write this equation for frequency. So what will happen? Just write, we know that V is equal to F lambda. So if we want to put frequency per lambda, so what will we do? In the next step, we know that delta lambda is equal to H divided by m naught C 1 minus cos theta. This is the equation for lambda. Now in case of frequency, we know that V is equal to F lambda, or F is equal to V divided by lambda. In case of C, we will write that F is equal to C divided by lambda, where this is delta. So we know that delta lambda is equal to lambda dash minus lambda is equal to H divided by m naught C 1 minus cos theta, or in case of frequency, we will write that C divided by frequency dash minus C divided by frequency is equal to H divided by m naught C 1 minus cos theta. Now taking C constant, we will get that 1 minus f dash minus 1 over f is equal to H divided by m naught C 1 minus cos theta. Next, taking C on the opposite side, it will come to division. So H divided by m naught C will become H divided by m naught C square 1 minus cos theta, and here we will get 1 over f dash minus 1 over f, or we can also write this equation as 1 over f dash, taking it on the right side, we will get 1 over f